Today I messed around with the SERV SERV RISC processor. It's my first day, and I want to capture what I did before I forget what I did because I'm going to be off on doing other things for a little while. So here I put into a gist on GitHub. I'll post this link. Basically what I did, all the commands that I pulled out of my command history that were related. It's about 100 commands. So the first thing I did was I installed the FUSESOC from Olaf K's GitHub page. It's his build script. It looks pretty impressive for it could be adapted for many things, I think. But pretty much if you want to use these serve derivatives, I think you need this build tool. And then I cloned his serve processor and his subservient processor. The serve is, I think, the one that's for general use. The subservient, I think he targeted for he's got this ASIC project going where he's trying to put a lot of these cores onto an ASIC. So I think he's using the subservient for that, and this is for like what people use usually for the FPGA. Then I went and I simulated subservient with an Icarus. So he had like an Icarus iVerilog target. So I'm familiar with iVerilog, so I was able to run that. That went well. Then I went with Servant, which is part of the SERV repo. So SERV, I believe, is just like the core. It's a very small core, and Servant is like a little infrastructure built around it. It's got some memory controllers, or like for like block RAM, or and things like that. Or maybe like a little GPIO. I don't know. It's got some stuff built around it that makes it kind of more useful to plop down in an FPGA. So that's what Servant is. And so I simulated Servant with Verilator. I couldn't figure out how to get it working with Icarus. Um, but it's the first time I played with Verilator. I didn't really look into it, so I don't know much about it yet. Except, well, I do know that it's like basically it compiles the Verilog code into C++ code. The Verilog code has to be synthesizable. Um, and also it's like a two-state simulator instead of like a four-state simulator that iVerilog is. So it doesn't understand X's or Z's, to the best of my understanding. So potentially those could flow through, and you wouldn't catch those in a Verilator simulation. But I think its claim to fame is it's supposed to be blazingly fast. I can't really tell from, I don't have anything to compare it against, but I'll 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 play around more with Verilator in the near future, I hope. Um, so let's see, we got so this did simulate nicely. It came up with some good things. Some of this I'm going to try to walk through again just to give a flavor for it, so I get uh, um, give a flavor for what the screen does look like as the commands run. Then I installed the RISC. So one of the things I was like, there was a blinky, and I ran the blinky one with the Servant, and it never blinked. And I think it's because like they probably have like 1 second blink times or something, which takes forever to simulate. I think the only way you can see it is if you end up generating like a VCD waveform file, which ended up getting huge. So uh, so basically, like, I don't think we can run that. I think I'd just swap out my virtual machine's memory disk space if I tried to run much longer than I did. So I think so I was not able to get Blinky to work. So I said, all right, let's go and install the RISC-V GNU toolchain. And then I could compile my own Blinky. I failed at that, but we'll get to that in a moment. So I installed the RISC-V toolchain. It took about an hour and a half, and it's huge. It's very huge. It took I don't know, it's like 10 or 15 gig of my little virtual machine. So I might have to create a new virtual machine or somehow expand its memory. I don't remember how I created it. Anyway, but I was able to install it. I was able to create a stupid little hello world. And then I was able to compile it with this tool. Everything is in this /opt/RISC-V. I select that, and that's where I ended up putting it. And so the next thing I got to try to do is I got to figure out how to make a blinky that toggles fast, runs on the bare metal. Or I guess I could probably live with Zephyr or something else, but I gotta get some way to get something that runs, um, that I can actually run and I can get into a hex file, put that into like a block RAM and run it and see that, woohoo, look, it blinks. So that'll be lovely. If that happens, then I can start making this, um, RISC-Vs, put them up onto some of the GPIOs, and have a nice configurable GPIO pin controlled by one of the SERV processors. So that's kind of my end goal. We'll see if we ever get there. Um, so anyway, the rest is, so I've done this. So I've done some of the installs, but I'll talk through it just to make sure. So, we got to install, you need pip. So Python 3, so I had to install pip. Make sure you run in Python 3. If not, then install that as well. You always do update and upgrade before, or at least update before you install something. Uh, um, then let's see. Then I made a directory called serve risk v, which is where and then I made a workspace inside of that, cd down to the workspace. A lot of this comes right out of Olaf's README. Then we blast through it. See, we make that. Then we use this FUSESOC, which adds all of these, like these cores and the SERV and the SUBSERVIENT. So he must have these formatted in some nice way. He's got some nice documentation on FUSESOC. I haven't read it yet. And then here we refuse, we were doing some runs. So I ran like this sim hello on Icarus, and I had to change the timeouts. And as I increased the timeout, it would print more and more of its message. And that just shows some statistics on it somehow. I'm not sure really what, but it's not matter. Doesn't really matter too much. Yeah, I couldn't get, again, like I said, I couldn't get SUBSERVIENT to work on iVerilog. Uh, so so this was with Subservient, which is the model that's designed to go into an ASIC. I think I mentioned that earlier. So I switched over to Servant, which is basically targeting the FPGAs. So then I ended up having to install uh, Verilator. Some interesting commands is like sometimes when I do a history that shows all my command history, sometimes I pipe it to a grep and some like keyword that I'm looking for, and that'll just give me all the occurrences. So this will tell me all this without seeing all the other stuff. It's a nice way to filter out the history. I even have a command called HG, which does a history pipe grep. This export workspace creates like this environment variable becomes set to the current work directory. That's right out of the README from Olaf. Um, and here we're exporting and we're creating a serve path, a serve environment variable as well. Um, and here, I think this is where I started failing. I couldn't figure out how to get an Icarus target. So then I ended up going and I installed Verilator. Simple apt-get install worked fine. Um, let's see, Verilator also provides a lint capability. So ran that, looked good. Then I ran several different, like this Zephyr Hello, Zephyr Fill, which is like a philosopher's problem, and Zephyr Sync. So those all worked fine. I think I tried to aggressively make the philosopher run faster at 115, 200, and it didn't work. So I backed down to what was in the README of 57, 600. So, so there are speed limitations here. So again, this is my history piped into a grep. I love doing that. here I'm trying to run like the blinky. So I ran the blinky, and then I said, well, how do I get so I ran it as running for a while. I stopped it and I couldn't see any results. So then I said, how do I get a VCD file, a waveform, signal waveform file? So I think I did an 8-H, but then I think I ended up going to like the FUSESOC documentation, which pointed me to you need a dash dash VCD to capture VCDs. So I did that, and sure enough, it hides it down here at this path here, down build, servant, blah, 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 Verilator, TB, trace VCD. So it doesn't make it obvious where it hides it, but you can find that. And so in this command, this is kind of cool. So find dot returns all the files in whatever directory mentioned, and dot is the current directory. So it finds everything in the current directory's tree all the way down, and then you grep for VCD. There's other commands like a dash name and a few other options. I never quite remember them, but I do like the Unix notion of a command does one thing. So find for me just returns a list of files, and then I pipe it into grep to grab out whatever files I'm looking for. And so this returned, and I was able to find this file because of it. Um, so that's a nice handy command for me. Oh, also, this is command, interesting command, ls-ltr. What that does is ls-l, the L makes it so it provides the details. The T makes it sort by time, and the R makes it reverse sort. So the newest files end up at the very bottom. So essentially, if you had hundreds of files in a directory, it'd scroll them all by, and then sitting right above your prompt is the most recent files, which is often what I want. So I even have an alias that I called LTR that does this command. And then let's see. So then I opened up Waves to try to look for Blinky. Blinky wasn't blinking because I think it blinks at around a second or so, and the simulation was like only running like a few microseconds. I eventually ran it for like a few hundred microseconds, and it totally swamped my disk drive. Um, because these trace files, they're ASCII, so they're not compressed and they can get pretty big. Um, So anyway, so one of the things here is so I ran GTK Wave, that popped up a GUI that it was running, and it had my console, my terminal locked sort of in a way. So I had to do a Control Z, which puts GTK Wave into the background. Yeah, it suspends GTK Wave, and then to get it so it's still running in the background, you type in BG. So I just wanted to talk about the BG command for those who are not familiar with it. All right. And then so Blinky appears running, but I think it's too low. So try. So then I ended up running it for a really long time. This DF command. So that shows how much for all the disks that are on your system. It tells you how much is being used. And I was using after I found this guy. The LL gave me the details that said it was big, and I went to DF, and I think I had just a couple percent left on my disk drive. Um, so anyway, that's that. LL is the same as LS-L. And I went and I said, let's remove that. And then I said, and I did a DF, and a lot of my space came back. And then I went and I looked in this whole directory here, and I said, let's just get rid of that whole directory. So that's what I did. DF didn't add much more space. So the trace.vcd was the big consumer of my disk space. So then I said, all right, I need to I need to be able to build a blinky that has a fast toggle rate so that I can see it in the simulation. And so that meant that if I need to build it, I need this RISC-GNU toolchain. Um, this RISC-V GNU toolchain. It took an hour and a half to install. It took a long time, and it's very, very big. Not as big as my VCD file, but it is big. And so basically, you got to make sure you have all these things installed. Um, And then they recommended putting it into /opt/RISC-V, or at least that was their sample dummy directory. So I'm fine with that. It's a protected directory, so I had to make it with a sudo. And then I created a bin directory, which is where all the binary files would end up. Again with sudo. And then I changed the mod to 777, which gave the world read, write, and execute privileges to everything that's in this directory tree. And the -R, capital R, is for recursive. And then I did a touch just to see that I could write into this directory. I did a touch, which just creates a file if it doesn't exist, or it bumps the timestamp if it does exist. So I touched ABC, and then I did an ls of that file, and it did exist. So I can write into that directory. And then I needed to change the append the bin directory, this bin directory to the path. So it's just $. So this is how you append a directory to your path. And then here I am doing again, like that trick of a history piped into grep to find all my clone commands. And so they said, okay, this is what I want to clone. And so I pasted that in there, and it cloned this guy. And that was a quick one. A bunch of the tools in this are in like sub repos or sub modules. I forget what they call it. And it'll only install those. It'll pull those. The tool chain will pull those in as it needs them. But so like the initial the initial clone is very fast, and then we CD down into like the RISC toolchain, which is where everything got cloned to. You do a /configure with these options telling like where you're going to put stuff. I believe this is right, but I believe this is right. I'm not sure. I've got to find out from some documentation somewhere. Is this the right architecture for our RISC, for the SERV risks? And I'm not really quite sure on this ABI stuff. So I got to understand these options better. So this is what I did for now. Then after configure, do a make Linux. And so I believe that's what I wanted. And I believe that makes it so it runs on, the compiler runs on Linux, and it cross compiles to this. Not so sure, but I believe that's the case. Then I did a date just so I could keep track of while I was running. I typed in a date so that I could see what time it actually finished, and I went away for a few hours, and it took an hour and a half to install. Then I did a DF, and I saw, oh, I'm running out of space, but I think I still have enough to work with. And then I did an ls of the binary files, and I saw that the GCC compiler was called this. So I created a dummy little hello, world C. I did this, and I got an a.out file. And that's pretty much the steps that I did. Let's see if I can see 18 minutes to go. Let's kind of see if we can blast through them. So let's see, all of these. So up to pip 3, it's nothing really interesting. So I'm going to do this one here, which should go in and add all of these, like SERV and SUBSERVIENT, and it'll show the core. So I'm going to do all of these all at one fell stroke. Copy, paste, return, and you can see what scrolls by on the screen here. So you can get a flavor for that. And I guess that might be okay. That's an awful lot. But anyway, so that's those commands. Let's pretend it worked okay. I think it did. And then basically this here, copy, paste, return. And this is running, and it comes in and it says, hi. And then eventually, let's use this longest one here. Copy, paste. Now this is running on Icarus, which is sometimes viewed as a slower simulator. But I think I'm kind of happy with it. It looks pretty nice. I believe this is running Zephyr on this one. I know like with the ones down below, they were running Zephyr because they got Zephyr right in the name, so it's running like the Zephyr real-time operating system. I believe this one is too, but I can't. I, I'll eventually figure that out. Um, so let's see, and then we ran this guy here. What's this show here? Paste. And so that's what you see when you show something. So it was in the example in Olaf's README, so I did it. And the history, grep, paste, enter. Well, so you can see how it just pulls out all the ones with FUSESOC, and I got quite a few of those that I've been messing around with. Now then, what we want to do is we want to export. Let's do all of these right down to. Oh, actually, let's skip all of this. This pretty much is a failed attempt on Icarus. So now let's go in, and we've already installed a Verilator. So we ought to be able to run this lint. Paste, enter. So there's lint, not showing any problems, I guess. And then you can run you can run Zephyr hello on Verilator. Paste, enter. And thinking, give it a warning. It's running. It shouldn't take very long. I think it'll finish up. Look at that. Hello world service. Isn't that lovely? And now, then I tried to kick it up to 1152 for the philosopher. Might as well just show you what happens when I screwed up there. Copy, Control C, paste, enter. Now, this is pretty ugly. Whoa, so that's when I'm running at 115.200. So I Control C out. I said, let's go back to the recommended 57.600. Copy, paste. And this comes out looking pretty nice. I was pretty pleased with it. Is it running? Okay, here it goes. Check it out. You figure out holding a fork, thinking, eating, uh, starving, dropped a fork. Yeah, so if you're into this philosophy type of thing, there you go. Um, and so that seemed to work pretty nicely. So then I did a Control C, I did a clear, and then I went down to this last one, which was this Zephyr Sync. Copy, paste, enter. And it came through and it's got these threads A and B. I think so they must be talking to each other somehow with two threads, each one doing a hello world ping-ponging back to each other. So that was kind of cool. And so I was happy pappy there. Um, and I said, okay, so that's when I claimed it worked. And then I said, let's see, I wanted to do this. Let's copy. Let's just show you what happens with all the run commands I've done here. So this history piped into run. See, so you get to see all your runs and you know what to pick out. And I claimed that I wanted to do this copy, paste a blinky, and hit it enter. And here it is. It's just running and running and running, and it doesn't do anything for you. What am I supposed to do with this? So it's toggling and everything. I think probably if I was smart enough, I'd like to go in and make it so that whenever the GPIO toggles, we print a little print statement out saying GPIO transition to high, GPIO transition low, and give the time when it transitioned. I should be able to hack the test bench to do that. Um, maybe that will be my next project before I actually get Blinky working right. Yeah, yeah, that's not a bad idea. And then so then I said, all right, let's see what. All right, so then I said, let's kind of like do this here. Copy, Control C, because it's nothing going on here, but it does show that it's running, which I'm kind of happy about. Paste. So this is essentially the same command I've added on the -- VCD to try to get waveforms for it. Yeah, it's running for a while, 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 running for a while. And then there's Control C. And now then, find dot. So find return all the files from the current directory and all its subdirectories, and grep for VCD. And look at that, we got this trace VCD. So then you can GTK. Let's see, I think I've got GTK wave already opened. Let's close it. Save. Oh, cancel. Oh, cancel. That's not what I want to do. Click on this guy. That's better. GTK wave load space file system root. There's a little bit left. I don't know what to do. That's probably because of this guy. Let's see if we can hopefully get through it here. So I went and I opened it up. It gives you the waveform viewer. Thinking, probably having a really hard time because we're low on disk space. Usually it pops up much faster than this. Usually it's much faster than this. Let's see. So top. So you click on top. See this Q? I believe that is um, the GPIO pin that goes to the LED. I'm gonna append it here, and then I'm gonna zoom full scale by clicking here. And see, there's no toggling. So let's close this down here, and let's go down to this. Let's just get a flavor for how big this is. Holy moly! Just in that short amount of time. Let's see, K meg. So it's 13 meg, that the 13 gig that this file is taking up here. So let's just get rid of him. So tracing is not a great idea on really long simulations. Right? I also did a DF. I should have done that before, but now the DF is yeah, right here. So I'm still at 95%. I'm gonna have problems because I only made my virtual machine 30 gig. And we're using 27 gig now, and that's because I installed the Verilator tools. So anyway, I'm sorry. I installed the RISC-V GNU toolchain. So where were we here? So Zephyr running Blinky. So Blinky's a fail at the moment just because it takes too long to blink. But I've got an idea on how to do it. So I think I'm kind of maybe I can hack that test bench. Um, and do some useful printouts. Um, so this is still again with bad news, too big, too big, too big, too big. So that's all too big. Now that I went and I installed the RISC-V toolchain, this is just an app, a sudo apt-get. Uh, Usually you want to, I just did an update just at the beginning of the script, but you want an update, the sudo apt update. And I made this directory. Um, so might as well just take a look see and let's do an ls of this. Copy ls, and so here are all the binary files that were created. Just do something. Read out. I'm looking for a tool that would convert like an ELF file to a hex file. Something in here has got to be able to create a hex file, I would believe. I'm not sure what yet, so we got to figure that out. So anyway, I've got that installed. I went and I created like a stupid little hello world. I just ran it. So there's really nothing much there. Just this command here. Unless you doubt that I could actually do it. All right, so let's do it. Hello.c. Oops, VI. Hello.c. Look at that. That's a comma. See, got me nervous. Hello.c. I pound include io.h int main print dash hello sorry return 0 close squiggle. There you go. Uh-oh. Escape. Okay. Foo. And then there was this command here, which is here. Copy. And make it a little longer. Paste. Something's bad. Oh, I shouldn't have just resized it. Oh. All right, so I did an ls, and here it created the a dot out. Oh boy, did I ever get this thing mad at me. So I think it's getting close to a good time to stop. That was all the commands. That's as far as I got. I got to figure out how to get a dot out to be compiled for a bare metal. Help, please. All right, that's it. Best of luck to everybody. Good night. And I probably won't be doing any more RISC-V stuff for quite a while. All right, shut down.